interval notation is an efficient way to represent a set of numbers along an unbounded or bounded interval. So we'll say it's an efficient way to represent a set of numbers along a bounded or unbounded interval. Now the formatting is you're going to use, so it utilizes parentheses or brackets to indicate if an endpoint of the interval is included or excluded. From the set. Now, why is it important to look at the endpoints? Because the interval notation is only looking at the two endpoints. So you list the two endpoints of the interval from least to greatest. So this is important here. Least to greatest always. So there's two types, as I mentioned before. We either have bounded or unbounded intervals. So we are going to look at both of those individually, and then you will get to see the actual notation. So we have this chart here. We're going to go from inequality notation, which is using those less than, greater than, less than or equal to, greater than or equal to symbols. And then we'll convert that over to what it looks like on a number line, and then we'll jump over to our interval notation, which is actually the goal of the video. So for inequality notation, you could have four bounded scenarios. Bounded means it's going to be between two real numbers. So the interval falls between two real numbers. And we're going to call them A and B, where A is less than B. So think A and B, say they're 1 and 5, okay, where A would be 1, B would be 5. So we just want to write a general notation for all of these. So for inequality notation, the first possibility is our variable x. So x represents all of these numbers in the set, or any of the possibilities. They're going to be caught between A and B, where A and B are not included. So this reads A as less than X, which is less than B. You could have A be included in the set, and in that case, we would use that less than or equal to sign. So that indicates inclusion. We could have A is not included, but B is included this time. Or we could have that they are both included in the set. Okay, so we're looking at X being all the numbers between A and B, and then the four possibilities break down whether or not A and B are actually included themselves. So let's put these on a number line. So because they're falling between two numbers, let's just plot A and B on all of these to start. Now, first one, X is between A and B. Now, A and B are not included. When something's not included in the set, we're going to put open circles on that value and then fill in what's in between. So that would represent everything in between A and B, with the exception of including A and B. Now, let's say A is included. What's the difference? We're now going to put a closed circle to indicate that point is accounted for. B is not included, so open, fill in between. Next, A is not included, B is included. And then lastly, they're both included, so close circles. So before we move into the actual interval notation, let's just take a note. Open circle means excluded. Closed circle means included. And then likewise, less than or greater than, excluded. Less than or equal to, greater than or equal to, included. We already mentioned before that we're going to be using parentheses or brackets to indicate exclusion or inclusion in interval notation. So parentheses mean exclusion or excluded. I'll stay consistent. And brackets indicates included. Okay, so when we do interval notation, all you have to do is list the endpoints of the interval. So that is what we will do first. The endpoints of the interval are A and B in these abstract examples. So we have A and B, and we list from least to greatest. So A is less than B, that was pre-established up here. So when I carry it down, again, we always list from least to greatest. Now, all we have left to do is put parentheses or brackets around these values to indicate if they're included or excluded. Both of these are excluded, so it's parenthesis, parenthesis around both. Again, the interval runs between the same points for all of these, so we can carry this AB down. In the second example, A is included, and I know that because of the closed circle on the number line or the less than or equal to sign in the inequality notation, so I'm going to put a bracket around it. B is not included. The third example, A excluded, B included. And the last one, both included. So when we see brackets, that means inclusion, parentheses, exclusion. Now jumping over to unbounded. Unbounded means that the interval extends forever in one or both directions. So the interval extends forever in one or both directions. We're just going to use a single number here, A, and now let's list the possibilities. So we could have X, let's thin out this line a bit. Okay, so we could have X is greater than A. We could have X is greater than or equal to A. We could have X is less than A, X is less than or equal to A, or we could just have X be any number. So this, in this case, the inequality notation, there is no inequality notation for this, so we're just going to say it's all real numbers. Now again, what side the inequality opens up to, you read it as that side is the greater than one, so X, and then it opens up to X, so X would indicate it's greater than A. So just make sure you understand that. Now, number line possibilities. We're only dealing with one number here, it's just A, and it extends in some direction. The last one is just all real numbers, so we won't have that. The first one, X is greater than A. So if A is some value, any value that's greater than that would be moving in the positive direction, which is moving right on a number line, because the numbers on a number line work from least to greatest. So A is not included based on the inequality notation, so I put an open circle, and it's everything greater than. So I would shade to the right. Now it extends forever, so I want to make sure that an arrow is shown at the end of that number line. Greater than or equal to would now indicate that A is included, and then all other numbers remain the same from the previous example. Less than A, so A not included, but everything less than it is included in the set. So I highlight everything that would be shown to the left of A, because now we're going in the negative direction. in relation to A, and then less than or equal to, close the circle, fill it in. Now the last possibility is included because we just want a way to show that it could extend forever in both directions, the interval. And that would indicate I'm including all possibilities of numbers that are real. So the whole number line would be shaded. Now let's jump over to interval notation. We already know that interval notation, we put the two endpoints of the interval. Now, the least endpoint, or the smallest value in the interval, or the leftmost endpoint. So again, another way you can think of it, leftmost endpoint, comma, rightmost endpoint. So the leftmost endpoint in this case is A, and then it goes forever to the right. So I need some other value to represent that it's going forever, and it's going in the positive direction forever, so I put a positive infinity. Now, A is not included, so I'm going to put a parenthesis. And then always, always, always with infinities, because it's not an actual number, and because that number cannot therefore be included in the set, I'm not indicating there's any stopping point or any inclusion of that value. It just keeps going. So infinities always have parentheses. A, leftmost endpoint, or the smallest number in the set, it is included this time, so we put a bracket, extends forever in the positive direction, parentheses always around infinities. Next, leftmost endpoint, rightmost endpoint. So a common mistake here is people want to put A again, but again, we always want to list least to greatest. So what's the leftmost? Well, it goes forever to the left, but in the negative direction. So we put negative infinity, always parentheses around it, and it goes as far to the right as A. It stops at A, but A is not included, so parentheses. Same idea here. It goes forever to the left, so in the negative direction, it goes towards infinity, always parenthesis around infinity, as far right as A, so A is the greatest number in the set. It's included, so bracket. And then how do we do all real numbers? Maybe you can figure this out on your own, but it extends forever in both directions, so we're going to utilize two infinities, one showing the negative, and then it extends forever in the positive direction. So these are the unbounded possibilities. To wrap up this video, let's look at some quick examples. Convert from inequality to interval notation. So with inequality notation, if you need help, you can read this off as x is greater than. Oftentimes, when we go from inequality to interval, some students use a number line to help. Okay, I will do that just to show you. So if I draw my number line and I put 3, I want to show that it would be all values greater than 3. 3 is not included because there's no greater than or equal to. Everything to the right. So that sometimes can help students with the correct interval notation. So my interval notation, which is going to be my final answer, we put our two endpoints of the interval. The leftmost is 3. The rightmost, it goes forever to infinity. Infinities always have parentheses. 3 is not included. So there's my interval notation for number 1. For number 2, it's caught between two numbers. They are showing you the two numbers that you need in your interval notation. So I'm just going to write down the two from least to greatest. Now, I just need to indicate if they are included. -2 is not included because it's just greater than. And then 6 is included, because x is less than or equal to 6. So I put a bracket, and there's my interval notation for that. So if you want to draw a number line, you can. In number 1, that helped. But number 2, when it's a bounded interval, so we can even make note, let's make sure we can recognize that this first one was unbounded. It's extending forever. The second one is bounded. Let's jump down to, if I have interval notation, how do we go back to inequality notation? Here's the shortcut that helps a lot of students. You write first number, leave some space, a variable, leave some space, the second number. Then the inequalities, the pointed part of the inequality always faces left because we're listing from least to greatest. So they always face left. Then I just need to decide, do I need to put a line underneath to show that the values are included? I see two brackets, so both of them are included, so I want to indicate that x could be equal to both of those. Continuing that theme, I write the left number, leave some space, x. Arrow's always facing left. Then check to see if I need a equal sign underneath. Remember, with infinities, it's always parenthesis around it, so I'll never need an equal sign with the infinity. And then the -5 out of the parentheses, so that does not need a line underneath to indicate that it is included. Now, here's the last step. Anytime I have infinity in my inequality notation, it's not typically written like that, and you shouldn't write it like that because you don't want to imply that that looks like some number that it's bounded between. So you always erase infinities. So we'll take a number. So if you want to take a note of that, star that somewhere. If you're going to use this technique, always erase infinities. Now this next one, 0, some space, infinity. Always face left if you're going to use this technique. 0 is included, infinity is never included. Because I have an infinity in my interval, I'm going to erase. Now, I can see that it's formatted like this. However, it's good practice to always write x first if you have an unbounded interval. So we're just going to flip this over. We're going to write x first, and we're just going to make sure our inequality is still facing the same direction, or opening up to the same thing, I should say. So I want to make sure it's still opening up to x. So just take note of that. That when I reformat to write x first, because that's just good practice, make sure that thing still opens up towards what it was originally opening up to. Okay, so this part here is really the better of the two notation, even though the first one's not wrong. Okay, you'll notice that this one was already x and then the value. Okay, but those are just some examples, and that is interval notation.